Hello friends, in this video I am going to solve this paper of 2022 thermal physics, Dibrugarh University. Right, third semester physics CBCS C-6 paper. And so before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you. And if you want to follow me on Insta, this is my Insta ID, Oja Lekajit LAKHYAJIT 123. This is my Insta ID. Okay, so follow me on Insta. So now let's start. So here is the first question, MCQ. Okay, in isochoric process, the first law of thermodynamics is, now you see in isochoric process the volume is constant. So if the volume is constant, then change in volume, that's going to be equal to 0. And we know that work done, W is equal to P dV. Okay, so if the change in volume 0, then work done going to be equal to 0. So that's why you say first law of thermodynamics, dq is equal to dw plus du. So if work done is equal to 0, then dq must be equal to du. So this is the correct option number 2. Right, so hope you have understood this. So now let's move on to next question. So our next question is, if in a Carnot engine, if the temperature of the source and sink is increased by the same amount, the efficiency of engine will be. So what will be the efficiency? We know in case of Carnot engine, efficiency is given by 1 minus T2 by T1. So T2 is the temperature of sink and T1 is the temperature of source. Right, now let me give you an example. Suppose here you see temperature of the sink is suppose 4 degrees Celsius and sink is suppose 100 degrees Celsius. Okay, so then what will be the efficiency? So 1 minus, so 0.04, that's gonna be 0.96. okay, that's gonna be the efficiency. Add 100 here and here also, let me add 100. So then what we're gonna have? So in that case, so we have increased the temperature of sink and source by equal amount. In that case, what we're gonna have here, you see 1 minus, so it's gonna be 104 by 200. So that's gonna be 100. If you cancel it by 2, then 52. So then 1 minus, so here it's gonna be 0.52. so now here you see this is gonna be 8.48, right? So here, so when we had 4 by 10, in that case we had got 0.04 and efficiency was 0.96. now the efficiency is decreased, so answer will be this number 2, decrease. Okay, so hope you have understood this. So what is the next question? In which of the following processes entropy remains constant? Okay, and the next question is, in which of the following process entropy remains constant? So that is adiabatic process. Okay, so in case of adiabatic compression, we are here entropy remains constant provided it is reversible. So here only it is adiabatic process mentioned, so we're gonna go with this option. Okay, so next, which of the following expression defines Gibbs free energy? Okay, so expression for Gibbs free energy is actually it is given by G is equal to H minus Ts, and H is equal to U plus PV. So here so that's why we can write G is equal to U plus PV minus Ts. So that's why this option is correct. Here you see U minus Ts plus PV. So this is the correct option, right? So next question, for an ideal gas, Joule Kelvin coefficient mu is, so that's gonna be 0. Third option is correct, right? So now let's move on to next question. So question number 2. So what do you mean by thermodynamic equilibrium? So let me answer this question. So here is the answer, thermodynamic equilibrium. So these are the conditions to be satisfied, for a system to be in thermodynamic equilibrium. So take the screenshot and write the answer. Okay, so now let's move on to the next question. So here is the question number 2b answer. Okay, so difference between reversible and irreversible process. This is the page number 1 and this is page number 2 beyond the blue line. Okay, and just take a screenshot or just pause the video and note it down. Okay, now let me go to the next slide. This is page number 3 and this is page number 4. Okay, so these are the differences, and let me check in the next slide. Okay, I think that's enough. Okay, first, second, third, fourth. Okay, so now let's move on to the next question. So what is the next question? State Kelvin Planck's statement of second law of thermodynamics. So what was that statement? Let me tell you now. So question number 2c answer. Sorry, 2c. First, let me write the Kelvin statement. Kelvin's statement. Okay, so according to him, it is impossible to get a continuous supply of work from a body by cooling it to a temperature lower than its surrounding. So here is the Kelvin's statement. It is impossible to get a continuous supply of work from a body by cooling it to a temperature lower than its surrounding. So now let me write the Planck's statement. Okay, so Planck's statement says that it is impossible to construct an engine, right, who is working in a complete cycle will produce no effect other than the raising of the weight. So this is the statement. It is impossible to construct an engine who is working in a complete cycle will produce no effect other than the raising of weight and cooling of a heat reservoir. So these are the two statements. So now pause the video and note it or take the screenshot. Now let me go back to the question paper. So now next question is draw the temperature entropy diagram of Carnot cycle. So let me show you the diagram. So here is this this is the temperature entropy diagram, okay, for Carnot cycle. So this is question number 2d answer, right? This is the temperature entropy diagram. So here I have mentioned 1 to 2 which process represents, okay, isothermal, adiabatic, whatever. Okay, then 2 to 3 adiabatic, 3 to 4 isothermal, 4 to 1 adiabatic compression expression. So these are mentioned above. Okay, so now let's move on to the next question. So what do you mean by adiabatic demagnetization? So question number 2e answer. This is the question number 2e answer. 2e. Okay, first write this one, then write this. Okay, so now let's move on to next question. Okay, first let me do one thing. I will make another video. Okay, after this I will continue from question number 3. Okay, so till then watch this video, and if you like this video, hit the thumbs up button. Okay, thank you for watching. See you in the next video. Just after 1 hour this next video will be uploaded.